And black screen. Okay. Hope the link is the same. Is the reason why I dislike this online education. I hope it went down only on the video. Okay, this task. There are two ways to solve this task. One is easy way, as I explained during the class, but as I know, most of you didn't get how it works, didn't try it at home. It's the reason why you didn't solve it. Or you may use other ways. I will explain on my way. So, it will be x, y. After this we have, let's use other marker. It will be x prime, y prime, and x prime prime, y prime prime. If we are using concept of homogeneous transformation and pure translation, pure rotation, how can we solve this task? After this, I need to rotate. Rotate around the axis on 80 degrees. Now I'm like this. Next step, to transform it there. So I can translate it according to x-axis on -1. You can count there that -1 and 1, 2, 3, 4, 5, 6. And ty 6. After this, we have a bit tricky moment. But we can solve, actually it doesn't matter how we will solve it now or later. Okay, we have it like this now. We need to rotate it. So it will be 180 degrees plus 36. RZ. But what's the next step? Actually, you may see that in this case we will have the same angle, but it will be y and it will be x. What can we do? We can rotate around y-axis, for instance. So now it looks like this. I mean, we have like this. So x, y, rotate around the y-axis. And we will receive needed result. Also, you can call it like a mirroring, because actually in affine transformation, as I know, Vladimir should show it during the class, but we will cover affine transformation later. So now we need to write it. Let's write. We know that this guy is cosine minus sine, sine cosine. How it's appeared? Who knows? Oh. Why we know that it's rotation matrix? How it's appeared? You didn't even try it at home. So actually, it's good question. Oleg or Vladimir gave it to you, but you didn't even try to understand why it's like this. Actually, It's appeared because, see, let's complete it in 2D, but actually you can do it in 3D, and we need it because we need to rotate it around y-axis. We have one angle, and let's rotate it like this. So x prime, y prime. After this, so what is it actually? It's x, x, y, y. We try to, let's say, project our solution on this coordinate. So x, x, x on x-axis, cosine alpha, because cosine minus x on I. We have x there, y there. As you may see that in opposite, I mean, it's an opposite way, so it will be there, minus sign, because our original was this, and we go later, so minus sign. So sine, cosine. So you just need to. So if you forget this equation, actually you can just Google it. But if you forget, you can derive it using this way. Okay, about this task. Oh, actually, can we write another matter? This one. Yes, we can rewrite it, and it will be like the same. This one. And after this, we can firstly rotate around y-axis. So we were like this. We rotated. X, y. We just need to make 90 degrees plus phi. So it's also the case. So is it important the order of rotations? The answer is yes. We just check it using hypothesis. Can I change? Can I first rotate, after this rotate again another angle? I just ask the hypothesis, I check it. Yes, it seems right. Of course, I can calculate it for this matrix, and receive that it's the same. Now I have deeper knowledge in this domain than it was about 10 minutes ago. Okay, how to write it? This guy. We know cosine, minus sine, sine, cosine. Okay, this one. Minus 1, 0, 0, minus 1. 0, 0, 1, 0, 0. Actually, how it appeared? You have y there, y change direction, minus 1. X also change direction. So it's the reason why minus 1, minus 1. We can call it like we make a mirroring according to this plane. Minus 1, minus 1. I mean, this line. Boom. After this, translate. I don't want to write a lot, so I will just write. I will combine it because I think it's obvious that it can be like this. Even more, we can combine it now together. It will be minus 1, 0, 0, minus 1, 0, 0, 1, minus 1, 6. After this, we go to, okay, let's go from this one. If you don't know this equation, you can just think that we had like this, our x should be in opposite direction. We just drop z because we don't need it. Minus 1, 0, 0, 1. Because according to x-axis should change the direction. We have x like this, now it's minus 1. 0, 0, 0, 0, 1. And rotate. This rotation looks not so clear because it will be divided by 2, minus 2 divided by 2. But actually, when we start to sum up it, what changed between this and this one? This minus 1. It's appeared on only one place, this one. It will be 1 minus 1, 0, 0, 0, 0, minus 1, 6, 1. And as this we need to multiply on this one. But actually, if you write like this, I already put 2 out of 2 because you already wrote it correctly. If you did like this, it's already a 1.5. How much time I spent on these rotations? Probably less than 10 seconds. And I already have 1.5 because I know how to do it. Now I just need to multiply my matrix. Of course, how can do it without this knowledge? Dinar, how did you solve it? Or you didn't solve it? You should know that actually change the basis I got it only after the third time when I started to work with it. So first time it was on my master thesis or master degree in robotics. I didn't get it correctly fully. After this, when I started to teach linear algebra, and after this, finally when I had some problems, I decided to cover this topic. And only after this, I get how to work with it. Not only with the robotics, I mean, what the difference between, let's call it robotic chain devices and the geometrical? Of course, it's the same, but in geometrical, we have only rotations actually, and we change the bases. We have some ugly bases like, I don't know, like crocozebra, and we need to change to another crocozebra. In robotics, mainly we're working with orthonormal bases, and we just go from one orthonormal to another orthonormal. It's the difference. So, how can we write it? Do you remember this equation? B plus AX. Now case X
B
equals
is origin move and I is inverse matrix. We should write two equations with vectors. I can show how I.
Yes, actually we should just do. We have B and rotation first time, B plus A rotation around Z. I mean, and we go to the top to this place. After this, you just need to rotate, or not rotate, they make a mirroring. And after this, you need to rotate. We need transformation, so we don't have any coordinates. So x, you can assume that x equal to 0. It will be 0, 0. You can write either like this, but in this case, you have some summation. Of course, in this case, you need to put 0, 0. Summation, you will have some problems. Or in my case, just go straightforward and don't think. About, in general, about this problem, about changing the basis. Who opened the material, extra material? Did you get?
Yes, and I just used coordinates IG and solved with this coordinates.
Yes, you can do it like this, of course. Actually, just spend time open this extra material because it was made 2 years ago by Grodetsky, Professor Grodetsky. And actually, it's also helpful. Really, it's helpful. I also read it, and I refreshed how to derive it using these slides. This PDF before your class. Just spend. Yes, it won't be fast. I just spend 1-2 hours. You need to write it by your hand. Try to play. Try to get what's going on there. And then after this, you will get how to work with change the base because it also will be on the quiz or not the midterm. It's not easy topic at all. I agree with it. It's one of the most complicated in this course. I'd like to aware you about it. This guy. Actually, first of all, yes, you know what is it between vertex, edge, and face. I put it there because some of you didn't know about it. If you don't know, probably you will mess up with this task. After this, you need to know, okay, what does it mean parallelepiped? Do you remember this video of Friedrich Gram parallelepiped, Russian? I showed this video class ago. So if you know that for the pipe it can be made using three vectors, after this you need to say you don't need to write all 6 faces, but it should be equal to this is equal to this to this. And we just start to write A cross product B, and it should be norm. I solved this task. So you write this 3 times and receive 1.5. Yes, of course, this task is not easy because it's about because of calculations. But if you write all formulas, you can say that okay, you solved this task. Yes, you didn't put the equation. I mean, you didn't put numbers. At max, it will be 1 out of 2. But if you write the 3 equations in 1 minute, and you can solve other tasks. Either you will spend a lot of minutes solve this task and won't succeed. Any questions? Maybe other solutions?
Yeah. Why did you say 1 and 1/2? Because there is 2 points.
I mean, you didn't solve this task.
Ah.
You just wrote equations, 3 equations. You didn't solve it completely. Yes, 1.5.
Understand.
So this all 5 points cost to compute it. And 1.5 just wrote 3 equations.
Yes.
Because this task is about your understanding. Can you imagine this? So you need to write first of all that you don't need to find all 6 faces, only 3 of them, because they're equal. The second one, just to write that you need to find the magnitude of your vector of cross product. That's it. Piece of cake. And the last one. We didn't finish it during the class. I asked you to do it at home. I showed you the algorithm, but as I get that some of you didn't get how to solve this task. Now I will show. How many approaches, methods do you know how to solve this guy? Забирай. Я же говорю, забирай, я не знаю, зачем тебе. А вон там стоит. Это мое. Вон твоя совершенно. So, how many methods do you know? How did you solve this?
I use like triangular matrix.
Okay, you use ref, in general, row reduced echelon form, or yes, in case triangular matrix, and after this?
I got the main trace diagonal and show if there is 0 in this diagonal, then the rank changes. It's less rank.
Okay. Other ways?
We can find at least 2 vectors that are linearly independent, and that means that there is at least 2D plane basis, and there is no more than 3D plane.
Actually, in this task and second variant, the max rank is 3, and alpha doesn't matter in this case. How can we solve it? I will explain. First way, yes, using the row reduce. So we try to receive zeros. I mean on the triangle. Let's do it. You remember how I explained? We just can write zeros there. We don't need to think. We just need to multiply on this guy and minus from this to this. So we need to write this one, 3 alpha, 1 multiply on alpha, minus, so it will be 0, 6 minus 3 alpha, 6 minus 3 alpha, 3 minus alpha squared. Agree? This one, just multiply alpha minus 3, 0, 1 minus alpha. Will run change if we swap to columns?
No.
No.
If you don't know, check it at home again. I'd like to swap it. because of this, we have free rank. If we want to have a rank of 2, what we need to do? We need to receive that at least one column should be equal to 0. We can see alpha everywhere. It's the easiest one, because in this case, because we have triangular form. So in our case, that alpha should be equal to 0 and simultaneously equal to and equal to minus y, I mean equal to 1. Can it be? No. So the max rank is 3 despite of A. Just boom boom. It's not a very clear method in some cases because you need to think. Dinar, do you have questions now?
Why it should be equal to 1? I don't understand.
See, you have the zeros. Perfect.
Oh, yeah.
So we need to receive at least one column equal to 0.
One column?
Row.
Or just one number on diagonal?
We receive triangle. In this case, that how to say, if we want, so in triangular form, we will receive, how to say, it will be zeros. In this case, that on each column we will receive at least one guy who is not equal to 0. So remember that rank, it's either independent columns or independent rows. When you have triangular form, in this case, if you have some number there and 0, 0, it means that this is unique column. 2, we have this guy. In row reduced echelon form, it also should be equal to 0. But in just form, it's not equal to 0, this pivot, not equal to 0. Okay, so in this case, it's also unique. Because we cannot receive this guy from other directions, from this one and from this one. So we have rank of 3. Because its max rank can be equal to 3 because it's 4 by 3 matrix. And if we have 4 by 3, it's equal to 3, the minimum number of columns. After this, okay, try to reduce it to 2 rank. What we can do? We need to find one column on row that will be equal to 0. We look at this guy. But we can see that it should be equal to 3 and 1 simultaneously. In this case, it will be 0, 0, and we will have 2 rank.
You should check second row too, because there are 2 all.
You can check it, but actually it's not necessary in this case. How you can solve it another way? I told you, it's in some cases, yes.
We can use the method of minors.
Yes, and the problem is that in English, it's not very popular method. It's quite tough to find this method. In Russian, method accumulations minorov is very popular, and in every book you can find it. So it's just fact. I use this method too. I solved the stat first by using this method. After this, I decided to use ref. What the method is? First of all, we need to find at least one by one minor. Minus 1. Okay, at least one rank. Nice. After this, 2 by 2. Can we find it equal to 0?
Yes.
Yes, alpha should be equal to 2 because 1 is 6 minus alpha 3 equal to 0. Alpha should be 2. Okay, it's not clear. So if alpha equal to 2, it might be that it may be rank less than 2. But we need to check every possible minor. Actually, we can see that we have no alpha there, and it's not equal to 0. Because 6 on 1 minus 3 by 3 equal minus 3. It means that we found at least one 2 by 2 minor. Rank equal to 2. At least. Go further. 3 by 3. We need to write this. I will write it using my cheat sheet. It will be 118 minus 6 alpha minus 3 alpha minus 6 plus 3 alpha square minus 6 not equal to 0. We want to find this. we'll use some magic of simplification. Let's find discriminant. If you don't see that alpha equal to r, we can say, okay, we have imaginary part, let's go further. And we can find that 2 plus minus square root of 2y. Yeah, I found roots, but unfortunately, because it should be rational. So, if you cannot find roots, that it should be equal to 0, I mean, in this case, equal to 0. So we cannot solve this task. We found at least 3 by 3 non-red body. Okay, so 3 by 3. So max rank is 3. Hooray, it's. In this case, for me, minor's method is easier. But you also can use this one, because in this case, you can, let me say, prove by yourself that you're just doing the algorithm and you receive this one. In this case, you need to think that, okay, so in some cases it's easier, in some cases not, but it's up to you. To sum up, do you agree that all these tasks were on the class, or you might cover it at home, and it wasn't a very complicated, very time-consuming tasks? I see. Yes. Okay. So actually, we covered. Even when I explained it during the class, we spent about 1 hour and 20 minutes using videos, using this one. We just go briefly through each task. I also explained you how to rank it. As for me, as I did it by myself, all of the stuff. What else? Do you have any questions? Maybe some. Okay, just let's say. Okay. So this is probably it. Don't forget that I also have office hours, not on Tuesday. If you need some help, you can ask me. Right, Oleg, I need office hour. But in this case, you need to go and so you need to show that you are worthy to have an office hours. What does it mean? You show that you try something. You have some of your handwritings with some mistakes and so on. You can show me, Oleg, I tried to do it at home. I didn't get. Help me. If you just go visit class, visit lab, Oleg, I didn't get everything. Without questions. And I will say goodbye. So, if you spend time, I also ready to spend time on you. Otherwise, I don't see any reasons to do it. Because you're the best place will be this one. Okay, so that's it.